Hi everyone, this is Meizi Wu and I'm doing probability homework 2, question 2. For the question A, it is asking us to find the probability for the x2 output equals to 1. So the probability for x2 output equals to 1, they have two different conditions. The first one is when the x1 input is 0, so we times the probability of the x1 input equal to 0 plus the probability of the x1 input to 1, and also we times the probability for the x1 inputs to 1. So by the number that's given in the question, so we have 0.4 times 0.2 plus 0.7 times 0.8. We have 0.08 plus 0.56. That is equal to 0.64. For question B, it asks us to find the probability for x3 output equal to 1. We don't have to do the step-by-step as the x2. We have an easier way, that is, use the equation of the probability for x3 equals to 0, probability for x3 equals to 1. That is equal to 0.2, 0.8, which is for the x1 input to 0 and the probability for x1 input to 1 times the matrix, that is 0.6, 0.4, 0.3, 0.7, which is given in the question, means when the input to 0 and the next one output to 0 for the 0.6. And for here is input to 0, output to 1. And for here is input 1, output 0. And this one is input 1, output 1. And since we're doing for the x3, so we have to do the square, because if we only time this matrix once, that's the outcome for the x2. So this is x3, we have to do it twice. And we can rewrite the equation as times the matrix one time, and then times the matrix again. So we have 0.36, 0.64, which is we can see it is as same as the problem A. The output of the x2 equals to 1 is exactly the same. So we time the matrix again. Do the calculation. We can have 0.408 and 0.592. So therefore, the probability for the x3 outcome equals to 1 equals to 0.592. For question C, it asks us to find the probability while the x3 equals to 0 and the x1 equals to 2. We can, since we have the matrix and we are doing the time them twice for the x3, we can have a different matrix. And this matrix means output for the first one, output input to 0 and output x3 is 0. And input 0, output 1, input 1, output 0, input 1, output 1. And we're asking the probability for x1 equals to 0 while the x3 equals to 1. We can rewrite this as probability for x1 equal to 0 and x3 equals to 1 divided by the probability for x3 equals to 1. And this is equal to the probability for x3 equals to 1 while the x1 equals to 0 times the probability x1 equals to 0 divided by the probability for x3 equals to 1. Those two equations are exactly the same. Simplify this, not simplify, but put the number we calculated from the matrix that we know while the first one input is 0, the output equals 1 is 0.52 times 0.2 by the given, divided by 0.592 by the answer from the last question, equal to 0.104 divided by 0.592, that we have 0.176. For question D is also the same, but instead of n, we have infinity. So probability for x infinity equals to 0, and the probability for x infinity equals to 1 is when n goes to infinity, 0.2, 0.8, and also the matrix times n time. And therefore we have 0.2, 0.8 times matrix 3 over 7, 4 over 7, 3 over 7, 4 over 7. And we have the answer 3 over 7, 4 over 7. So the probability for the x n equals to n goes to infinity equals to 3 over 7.